Anyone? Somebody tell me something smart about spring energy. Yes, Devin.
It's conserved.
Okay, assuming an ideal spring, I'll grant you that. What do we know about this energy in a spring? What do you say? Oh, wait, like what is it? Oh, there's definitely a spring constant in there. Anybody want to?
Isn't it something along the lines of it's a restorative?
Yeah, it's a conservative force. Very good. So when we talk about total mechanical energy, it's kind of like gravitational potential energy because it's conservative in that sense. But is there a way I can express the spring potential energy? Somebody come up with it.
1/2 times spring constant times the distance it's being stretched.
Or compressed.
Yeah.
Squared. Correct. So spring potential energy is 1/2 kx squared. So realize if the spring is just laying on the table, nothing's going on, how much potential energy is in the spring? Zero. Right? There's nothing going on. If I stretch it and I hold it, does it have potential energy associated with it? Yes. If I let go, it'll go back the other direction, right? Likewise, if I compress it, it has potential energy and I let go, right? So, if we want to be complete in our world of completeness, and we talk about total mechanical energy in a system, I can say, well, if I had a spring, and I had a mass at some height, and I had some kinetic energy, that would be equal to you guys remember this? This is a complete expression of total mechanical energy to include two kinds of potential energy and one kind of kinetic energy. Well, there's only one kind of kinetic energy. Okay? So if I have a mass on a spring, like this, and this is a frictionless surface. If I were to think about my total energy for the system, can I get rid of some of these terms?
You don't need the MGH because you're not changing in height.
I don't. This thing's not going up and down, is it? So this positional potential energy due to gravity is not relevant to this particular problem. Okay. So in that sense, I can say, oh, what was that? That was the loudest sneeze ever.
I was too.
So in that sense, I can ignore gravitational potential energy. It's not relevant to this problem, correct? Okay. So if I grab this thing and I pull it to A and I hold it,
0.
zero what?
Kinetic energy.
Zero kinetic energy, but does it have spring potential energy? Yes. So if I call that position 1, no, right? How much kinetic energy would it, I'm sorry, how much spring potential energy does it actually have in the system?
Max.
It's the max, right? K A squared. If I were to pull it here and hold it, that's its original energy, right? Do you agree? Then if I let go, and I say, hey, how fast is it going when it gets here?
Max.
Okay? How much potential energy does it have when it passes through 0?
Zero.
None, because it's neither stretched nor compressed, correct? So I could, if I wanted to calculate the speed of the mass as it passes through 0. Or I could calculate any position in between A and negative A if I knew additional information, like how much it's stretched or compressed. Does that make sense? It's very quiet and it's concerning. Why is it concerning? I'm waving to the cameras.
Oh. I'm seeing that later.
I know.
I don't watch it.
She actually got my message about washing her hands before she eats, so that's good. Public health is my number one concern.
Mine too.
Not really.
Mine is.
Any questions about this? Go.
Will you have us resolve and put the amplitude of the problem as well?
Maybe.
Okay. Just
You'd have to have enough information,
yeah,
whatever it is, to answer the question.
alright.
So I know that 1/2 KEX squared is potential energy and 1/2 MV squared is kinetic energy, but
Mhm.
what is the symbol for MGH1?
It'd be like PE1, potential energy 1. Is that what you, this one?
Yeah, what's the symbol for that one? What is that shortened to?
Well, this would be spring potential energy. This is gravitational potential energy due to position.
Okay.
Does that help? And then this is KE1, whatever that might be. It's eerily quiet. It's scaring me still. Nothing? What? Yes.
So if we use gravitational potential energy, does that mean we have to use kinetic energy of gravity?
There isn't such a thing. Anything that moves has kinetic energy in any direction. In fact, it's a scalar, so direction is irrelevant.
Oh, I get it.
Okay? Hello. Devin's out there. I know that much. The rest of you are not.